All right, guys, welcome to lesson 6. We're going to talk about the average value theorem. All right. This little example here, which I believe you guys could probably figure out on your own with a little bit of thought, kind of captures the heart of our lesson today, which is the average value theorem. Sounds a lot like the mean value theorem, doesn't it? But they actually are different. There's some similarities, but there's a difference. So before I begin, I want you guys to ponder this. I've written up here a chart, and this chart is a prediction of the amount of product that will be required over a period of years. So this over here says resources demanded, and these are the years. So starting in 2014, ending in 2018. So in the year 2014, we would need let's say 2,000 units of a product that we're producing. But the next year we'll need 3,000 and so on. So I want you guys to pause the video here and I want you to answer this question I've got written off to the side. How much should be produced every year to meet the demand for the 5-year period? Now, you might think, well, they should just make 2,000 this year, 3,000 the next year, and 2016 they'll make 4 and so on. But actually, they want to set up their business so that they just make a steady amount every year, but they just want to make sure that they will have made enough to get them through all the way 2018. So they want to make the same amount every year, but it has to be enough to get them through the year 2018. So that's the idea. How much should be produced each year to meet the demand for this five-year period? So pause the video here and see if you can figure out what the answer is. And when you unpause it, I'll share with you the solution. All right. So the answer to our question here is 4 units, or 4,000 units, or whatever the amount is per year. How do we get that? Well, we know in the first year we need to produce 2, the next year 3, the next year 4, then 5, then 6. Altogether, that makes 20, and we need to do that over a period of 5 years. So that's 4 every year. In other words, what we just did was we found the average. An average is a process where you add together everything and divide by how many they are, and that will basically tell you how much you would have to divide up to each piece to make it balance out evenly, right? So that's the average amount. Now, I want to share with you guys something here. It's the average of the y values, but what I want to share with you is that there's something kind of significant about that. If I draw a horizontal line right here at 4, my average amount, do you guys notice something interesting about the amount that is above the line and the amount that is missing below the line? They're identical. In other words, and this just makes sense, right? If we wanted to figure out how much we need to make each year to settle the entire situation, the amount that we overproduce on some years should make up for the amount that we underproduce in other years. And that way you end up with a solid rectangle. Now, so here's what I want you guys to walk away from this. So first of all, the answer to the question is this is the average y value. And if we make a rectangle whose height is the average, the amount over the curve or the line, the amount over the average will equal the amount under the average line. It's the great equalizer. You know, you have some stuff that's going above and beyond, you have some stuff that's overperforming, and it just creates a level playing field. Okay? So that is the average value, and that's what we're talking about today. So what is the average value? Well, what they mean is it's the average y value. In other words, if you took all the y values and added them up and divided by the number of y values that you had, it's going to tell you the average y value, which if you were to draw a straight horizontal line there, however much is above that line should be exactly equal to how much is below it. So this right here is probably my favorite slide out of this entire lesson because it really communicates the whole point of what we're talking about today. What is the average y value? It's all the y values added together divided by the total number of y values. And geometrically, if you were to draw a rectangle whose height is the average value, the amount over should equal the amount under. All right, so keep that in mind. That's the coolest part of the lesson, in my opinion, here, because the rest of it is just details and calculus technicalities. So here we go. So I want you guys to do the same. Now, here's the problem. On the last slide, it was easy because we were dealing with just rectangles, and rectangles are easy to work with. But when you're dealing with a curve like this, it's a little bit harder. So I'm going to ask this question in two phases. The first phase, I want to leave it a little bit more open-ended, and then the second phase, I'll be a little bit more specific in case you didn't get it on the first try. So here's what I want you guys to do. Open-ended question number 1. What is the average value? Just take an estimate. It's an estimate. It's not going to be an exact answer. It's an estimate. Okay? So see if you could tell, based on what we just talked about, see if you could tell what the average value of this function would be. Pause the video and think about it for a second. If you don't know, I'll come back when you unpause it, and then I will share with you some other considerations. So, if you weren't able to answer the question yet, I'm going to give you a little hint by rephrasing the question. From the last slide, we saw that the average value is basically the y value that you would get if you were to add together all the y values and divide by how many there are. Now, that's impossible to do with this graph because there's an infinite number of y values. How are you going to add them all together and divide by how many there are? That's impossible. But the amazing thing is calculus is in the business of doing impossible things. It actually does add together an infinite number of things. But that aside, here, what's my hint? What's my helpful hint to you to help you find the average y value? Well, think of the graph. Remember what I told you? The average y value will create a horizontal line, which will create a situation where the amount of area that's above your average will exactly equal the amount that's missing below your average. So now see if you guys could draw a horizontal line that would do that, and now see if you could tell me the average value. Pause the video, take a shot at it. It doesn't have to be precisely right, it just has to be close. And when you unpause it, I'll share with you my solution. So if I were to draw a line like right here, I think that's too high. I think that's way too high. Why is that? Because look at this. This area right here in this little triangle and this little area here in this little semicircle looking shape in here. Do you think that if I were to put those three areas together, do you think that would be enough to fill in the missing blanks over here? I don't think that would be anywhere near enough. So we don't have enough area on top to fill in the missing area below. So let's drop that line down a little bit. Kind of got to be careful. You don't want to go too far. Let's try putting it here. All right. So now, do you guys think that if I took this area, and this area, do you think that all of that would fit in here? No, that's way too much. So now I went down too far. So let's try again. So I know I don't want to go up too high. I don't want to go too low. Let's try maybe right about here. I'm feeling like that might be a little bit high still. But I feel like, like this piece here, if we were to take some of that, that would definitely fill in this little circle here. Maybe these two would fill in this little circle area. And this one is close to filling in that one. But maybe we need to drop it down a little bit more. Let's drop it down a little more. But as you guys can see, there's not an exact answer here. We're just trying to get close. So I might go like this. I might say like right about here is a really good estimate for that. So if I were to take this little triangle right here, and this little triangle right here, and this little piece right here, I think those would probably get pretty close to filling in those missing blanks, so we end up with a nice flat rectangle. All right, and so I would say the average value of this is probably something pretty close to about 15 would be here, so I would estimate probably like 14-ish. So we have an estimate then for the average value. Now let's pull in a little bit more though about what we talked about. What we talked about is that the area of the purple region should be about the same as the area, well, not about, it actually should be exactly the same as the area of this rectangle whose height is the average value. So the area of this rectangle should be exactly equal to the area of the purple region. Now in calculus, we know how to get the area of that purple region pretty much exactly right. The area of that purple region is done by finding an integral. The integral of your function from your starting point, which is -1, up to your last point, which is 10. That tells you the area. Okay? So that's the area not only of the purple region, but also of the rectangle, whose height is the average value. Now, as you guys know, the area of a rectangle is base times height. So if you want to find the height, you divide by b on both sides, right? So the height is equal to the area divided by the base. The height of my rectangle represents the average value. Okay? So we know that this is the height over here of my rectangle is 14. And that represents my average value. So what do I do to the area of the rectangle to get the height? I divide it by the base. And you guys could tell what the base is. What's the base of that rectangle? The base of the rectangle goes from -1 to 10. In other words, it's 11. So if I do 10 minus a -1, I get 11. What we've just done then is I've just shown you that, okay, so we estimate our average values here. It creates a rectangle whose area is exactly equal to the area of the purple region. The area of the purple region is given by this integral. Now the area of the purple region, since it's the same as the area of the rectangle, if I divide that area by the base of the rectangle, that'll tell me the height of my rectangle, which is the average value. So what I've just done then is I've shown you guys a formula to find the average value. This is our formula to find the average y value, the average height of your function. So what you do is to find your average value is you integrate your function on the interval that you care about and then multiply that by the reciprocal of b minus a. In other words, the base of your rectangle. Okay? So that is how you find the average value of a function. Now I went ahead and I actually found the area of this function, and I think I got it to as 180. And so if I divide that by 11, we can actually find the actual average value, which should be hopefully close to 14. Let's see. 16. We were off a little bit. I think when I originally wrote this, I might have put a -2 here, so I might have to be a little bit higher anyway. But anyway, so we can actually use calculus now that we have this formula right here. Now that we have this formula, we can actually use calculus to find the average value of a function. So basically, you just do the integral. That gives you the total area. Divide it by the base, and that will tell you what the height of your average value rectangle is, which is your average value, right? So that's how you calculate the average value of a function. Okay, so let's actually go ahead and calculate an average value now. So example 1 says find the average value of the function on the indicated interval. Okay, In other words, now I want you guys to remember, what is an average value? It's an average height. Okay? So when you're dealing with a sine function, you know, it looks like this. You know, sine, you don't have to draw this, but I'm just drawing a picture right now, so you don't need to put this on your notes. But it has an amplitude of 2, I see. So it's gonna look something like this, and we're going from negative pi over 6 to pi over 2. And the question is, what's the average height of this function on the interval? You know, it has a height of there, has a height here, has a height here. What's the average height? What's the average y value is the question here. Now, how do you calculate this? Well, we're just going to use our formula. The way you find the average value is by using our little formula friend here, which is, first of all, you find the area of your function under the curve. And then you divide that by the base of the average value rectangle, and when you're done, you should have the average value height, which is the answer that we want. Okay, so my b in this case is pi over 2. It's your final x value. My a is negative pi over 6. So we're going to fill those in. Your first x value and your last x value. And then your function in this case is 2 sine x. Okay? So I'm going to do this by hand, something you can do on a calculator. In fact, I'll show you how to do it on a calculator a little later on the lesson. But for now, I do want you guys doing these by hand, unless I specifically say use your calculator. So on your homework, make sure that you guys are showing your work unless I say use a calculator. Okay? So first of all, let's simplify this ugly looking little thing here. I'm going to do that on the side real quick. That's not a very fun thing to look at. So I want to fix that. That's ugly. So let's multiply everything by 6. And we multiply by denominators. So here, the 6 on the top will reduce with the 2 to make 3. So we'll be left with 3 pi there. Here, the 6's cancel, leaving me with 1 pi. In the top, we got 6. And 3 pi minus 1 pi is 2 pi. And then that reduces to be 3 over pi. So we want to simplify our little fraction there in the front first if we can. So that becomes 3 over pi. And the rest of it's still going to sit here just the way that it was. Is that right? No, it's pi over 6, my bad. All right, now we're just going to do our integral. Okay, so the next thing after you simplify your little fraction here in the front is go ahead and take care of this. Now, since we're dealing with trig functions here, we don't really like to have those numbers on the inside. So I'm going to take this 2 out and put it in the front. So that means the 2 is going to multiply with the 3 over pi, which will give us 6 over pi. Alright, so step 1, simplify your fraction. Step 2, we're going to integrate. So we're ready to integrate now. So let's do this. So to do this problem, the first thing we're going to do is we're going to integrate the function. What is the integral of sine? Well, if you forgot, the integral of sine is negative cosine. All right? And then after that, we do our fundamental theorem of calculus. So here we go. So we have, well, I could probably need a little more space than that. 6 over pi, parenthesis minus parenthesis, negative cosine of pi over 6, actually negative pi over 6. And then negative cosine of pi over 2. All right, now if you guys were doing an FRQ test, I would stop right there. You don't need to simplify it any more than that, because I know that a lot of you guys are not real strong on remembering all your trig values anyway. But, you know, if we end up having a take-home AP exam and you have your little cheat sheet out where you can look at the trig values, then go ahead. Now, but, you know, what happens if we end up having a multiple choice test this year? Well, then you kind of got to remember it, and you don't get to look at your cheat sheet if they actually end up doing an in-person test. So we want to make sure that we're prepared for this. So I'm still going to work it out by hand, but just so you guys know, on an FRQ, I'm totally okay with you leaving it just like that. Now, first of all, cosine of pi over 2 is 0, so that whole thing just goes away. This is weird, though. Negative pi over 6. On our unit circle, positive pi over 6 is right here. So negative pi over 6 is down here. Positive angles go to the right, negative angles go, well, not to the right, they go counterclockwise. And the negative angles go clockwise. So negative pi over 6 is right here, and that's actually the same thing then as 11 pi over 6 on the normal unit circle. So instead of negative pi over 6, I'm going to put something in there that I am familiar with, 11 pi over 6. And cosine of 11 pi over 6, if I have my unit circle memorized, is radical 3 over 2. But I still have this negative here in the front, so I'm going to put that there. And then if we just multiply these fractions together, you get 6 times radical 3 on the top. And on the bottom we have pi times 2. And then we have the negative, of course, still. And then this can reduce here. So I end up with negative 3 radical 3 over pi. That would be my final answer. That would be the average height of the function. So I don't want you guys to get lost in the trig too much. I want you to remember the basic process. So, step 1. Set up your formula. It's 1 over b minus a integral a to b. Step 2. Simplify that fraction there. Step 3 is integrate your integral. Step 4, do your fundamental theorem of calculus to get your answer. So, 4-step process there to find your average value. But don't get lost in all the steps and details, okay? Remember, this is the area under the curve, which is equal to the average value rectangle's area. So if you divide the average value rectangle's area by its base, you get the average value rectangle's height, which is the average y value of the function, right? So let's go ahead and throw one of these at you guys here. So go ahead and do your 4-step process here. This is homework problem number 1. So once again, transition off of your notes and go to your homework now and start working on homework problem number 1. And don't use your calculators for anything. Just do it by hand. And when you're all done, unpause the video and you will see the solution. All right, and there you guys have it. The average value is 0. That's kind of interesting. So step 1, set up. Step 2, simplify the fraction in the front. Step 3, integrate. Step 4, fundamental theorem of calculus, and we end up with 0. Okay, so just for the heck of it, let's understand the results here a little bit. I'm going to graph this. You don't have to graph this if you don't want to. Just being a teacher here, so bear with me. So at negative 3, if I plug in negative 3, I get 2 times negative 3 is negative 6, plus 1 is negative 5. And if I plug in 2, I'm going to get 4 plus 1 is 5. Is that right? Okay, I guess so. And then we're going to draw our line. Now, look at the area below the curve and the area above the curve. What's the average y value? It makes sense that the average y value be right in the middle because the area below is exactly equal to the area above, that average value line. So there you have it. Makes a lot of sense. Okay, so that's how you calculate the average value of a function. All right, so let's do example 2 now. Same question, different context. Instead of dealing with an equation, I'm just going to give you a table. Well, when you have a table, you can't actually find the value of your integral. You can only estimate it using the Riemann sums that we talked about in 6.1 and 6.2. So, step one, let's do our setup. So my setup is 1 over b minus a times the integral from a to b of my function, right? This is how I will find my average y value. All right. Now, the next thing I'm going to do is I'm going to find my a and b. Now, the a and the b are the first x value and the last x value. So that would be 1 over 10 minus 0, which would look like this. Step 2, simplify your fraction there. So that's really simple to do. All right, now step 3 is to do your integration, right? But here's the problem. We can't actually integrate this. This is a table of values. So what we're going to do is we're going to estimate this using a trapezoidal sum. We don't know what the actual area under the curve is, but we're going to get a good estimate by doing a trapezoidal sum. So if you guys don't remember how to do that, then follow along with me here. When you're doing a trapezoidal sum, you start with the first two data points. The distance from the first x value to the next x value gives you your height. So in this case, my height equals 3. These two numbers here tell you what your bases are. Base 1 is 7, base 2 is 6. And the way that you calculate the area of a trapezoid is you do height over 2 multiplied by the bases added together, right? So it's going to be 3 over 2 times 7 plus 6, which is going to be 39 over 2 when we simplify the whole thing, okay? And you just kind of keep doing that for every consecutive pair of values. So the next one I'll look at would be the next pair. And so I'm just going to keep doing that until I get to the end. So in this case, my height is 3 again, and my bases this time are 6 and 8. So height over 2 multiplied by the sum of the bases is going to be 21. Next one. Height is 3 again. Bases are 7 and 8. So that would be 45 over 2. Last one. Height is 1. Bases are 7 and 6. So that would be height over 2 multiplied by the sum of the bases, which is 13 over 2. All right. Now in this case, I'm going to go ahead and add these together just so, well, I guess you don't really have to. But we're doing our integration right now, right? So we have 1/10. And even though we can't find what the actual integral is, we can estimate it using a trapezoidal sum, which is what this is down here. So now this piece becomes 39 over 2 plus 21 plus 45 over 2 plus 13 over 2. And once again, you really can just leave your answer like that. That's totally fine. And in fact, I think I will this time. I think I'll just leave it. But, you know, if you had a multiple choice test, maybe what you'd want to do is get a common denominator, or maybe just change everything to decimals. Doesn't matter. Whatever you want to do to simplify it, but that's our answer right there. So the average value is the area under the curve multiplied by the length of the multiplied or divided by the length of the base, which gives you the average height of your average value rectangle, and that's our answer. So that would be the average y value of the function. Now, some of you guys might think, well, Mr. Bailey, that's really hard. If somebody asked me to find the average y value, I would just add up all these y values and divide by 5. That won't work. The reason that won't work is these rectangles are not all the same length. The distance from here to here is 3, but the distance from here to here is 1. So even though this height on average goes from 7 to 6, that only takes up 1 space. Whereas like this one here, which goes from 8 to 7, that takes up 3 spaces. So you have a much longer interval where the height is greater than you do where the height is lesser. So because these heights are being spanned out over different intervals, you can't just add together all your y values and divide by 5. It won't work. You actually need to do the average value function that I just told you. So you guys get to try one here. For you, though, you're not going to do a trapezoid sum. You're going to do a left-handed sum. But other than that, it's all the same. So go ahead and pause the video here. This is homework problem number 3. Once again, transition into your homework and do the third problem on your homework worksheet. When you unpause the video, we'll go through it together. Okay, so step 1, set up your problem. Step 2, simplify the fraction in front. Step 3, we need to find the integral, which is over here. I've done my left-handed Riemann sum, and I came up with 13. So this becomes 13, and then multiplying that by 1/10 is 13/10, and that would be my average value. All right, guys, so the last thing, well, not the last thing I want to show you, but the next problem is I want to show you guys how you can use your calculator to do this, and it's not going to be all that mind-blowing. It's kind of similar to everything else we've done. We've been trying to use calculators for this stuff, but you can. And so this problem, for instance, you're not going to be able to find the average value by hand because we don't have a way to integrate something like this right now. You'll learn how to integrate something like that in Calc BC if you take it, but in our class we don't have a way to integrate that. So the only way for you to do it is by hand. So we want to stick with our first 2 steps anyway, where we start by doing our setup. Simplifying our fraction in the front. So you still want to do your first 2 steps. You want to get it all set up and ready to go. But after that, we're going to let the calculator do the rest for us. Okay, and then we'll be done. It's that simple. So I'm just going to show you guys how to type that into the calculator, and then we'll be having our answer. Okay, so let's turn on our calculator here. I'm going to clear it. Second plus 712. You don't have to do that if you don't want to, but that just clears up your memory so you don't have any garbage on there from the last time you used it. So we're going to go to y equals, and we're going to put our function in there that we're working with. We're doing e to the x power multiplied by x squared. So there's my function. Then I'm going to push second and quit to go back to my home screen. Once you're there, we're going to pull up the integral. That's accomplished by pushing the button for math. You're going to scroll down to number 9, or you can just push 9, and you get this. You're going to put your lower limit in here. You're going to put your upper limit in here. And then you're going to put the y1 function that we just typed in under the y equals button here. And once again, the way you get that is by pushing vars, scrolling over to y vars, push 1 for function, and select y1. And that's the function that we typed in earlier. And then, of course, we want to put our variable of integration and push enter. Now, that's just the integral, right? So actually, let me back up a little bit. I'm going to push, before I even entered this, you know what I should have put is I forgot to put the fraction in the front, right? So let me insert that. I'm going to push second and insert. And by the way, if you guys don't know how to pull back what you had already typed, you just push second and enter, and it will bring back for you the last thing that you typed in. So I made a boo-boo, so I need to re-enter everything, and that's the fast way to do it. Now I want to insert that fraction in the front that I have, which was 1/2. So you push second and then this button here to insert after you put your cursor where you want it. And then for fractions, you typically want to put them in parentheses, 1/2. And then that's good. So now I've got 1/2 in front of that, and you push enter, and that should give us a better answer. So there's the average value of this function. So when you guys do it, don't forget to put the fraction in the front like I did when you type out your integral. So there's that. Let's go back to our slide here, and Let you guys try one. So why don't you guys see if you can use your calculator to calculate this average value of this function on this interval. This is your homework problem number 7. So once again, go ahead and pause the video here, move on to your homework worksheet, and work on number 7. When you unpause the video, I'll share with you my results. You get negative 0.586 is the y value there. So that's the average height of this function on the interval from 0 to 3. Okay? All right, so now let's go ahead and talk about the mean value theorem. That's something we talked about back in unit 4, I think it was, or maybe it was 5. Anyway, the mean value theorem is a theorem that tells us that if a function is continuous on a closed interval and differentiable on the open interval, there must be some value of x that we'll call c, where the instantaneous rate of change is equal to the average rate of change. Now, I'm going to talk about this for 2 reasons. One, because the mean value theorem, that sounds almost like the same thing as the average value theorem. I mean, they're almost identical. The problem, the only difference is one says mean, one says average, but I don't know if you guys remember, but in math, typically average and mean mean the same thing. So is there a difference? Well, there is a difference, a very important difference. But at the same time, they actually do have some very interesting similarities, and there's a cool relationship to them. So I wanted to spend some time talking about that. And that's important when it comes to test questions and stuff like that. Since they sound so similar, it's very important that you recognize their differences and know when to apply these different circumstances in different situations. So let's go ahead and compare and contrast the mean value theorem with the average value theorem. Let me get rid of these boxes here real quick. All right, so first of all, the mean value theorem is a concept that has to do with derivatives. Mean value theorem is all about derivatives. We learned about it when we were doing derivative discussions. The average value theorem, in case you haven't noticed, today is all about integrals. So this is a derivative concept, and AVT is an integral concept. Okay. Now, what I really want you guys to understand is that this thing, the mean value theorem, helps you find the point in time when your instantaneous rate of change equals your average rate. In other words, it finds the point in time when the instantaneous rate f prime of c is equal to the average rate, which is given by the slope formula here. So in other words, it finds an average rate. An average rate. Whereas the average value theorem finds you an average value of y. Okay, so the mean value theorem helps you find the average slope, whereas average value theorem helps you find the average y value. Okay, so that's a very important difference. You have to understand what the difference is between those in the sense of what they are. The mean value helps you find the average rate. This one helps you find the average y value. This one's a derivative concept. This is an integral concept. Now, the next thing I want you guys to be aware of is the geometry associated with these. For the mean value theorem, if I give you a function from point A to point B, we are looking for that sweet spot where the average rate of change equals the instantaneous rate of change. In other words, the tangent line is parallel to the secant line. It's all about slopes, right? When it comes to the average value function, we had the geometry for that today. The average value function is something that helps you find that point in time, or that y value, I should say, where the area above equals the area below. So I want you very much to understand how these things are different from each other conceptually. Conceptually, this is about finding the place when the slopes match. The instantaneous slope matches the average slope. This is about finding where the average height of the function is located. So that's a major difference in concepts. They're almost like two completely different ideas. Okay? But also I want you not just to know how they're different conceptually, but I also want you guys to recognize how they are different in their processes and how you can identify them in a question. Okay? So let's talk about that. When you need to use the mean value theorem, the question will ask, to find the average rate. Okay. Now there's other times when they'll ask you to find the average rate, and you don't necessarily have to do the mean value theorem, but you do have to do that f of b minus f of a over b minus a every time they say find the average rate. Okay. In that case, you're doing an f of b minus f of a over b minus a, and sometimes you're doing the derivative thing. Okay. For the average value theorem, the question will ask to find the average value. So if you see a question say find the average value, they want you to do this. That's what they want. So when you see find the average value, they want that process right there. When they say find the average rate, they mean this guy right here. Those are two completely different things. Okay? So you've got to recognize they both say average, but the one that says average rate is this formula. The one that says average value is this formula. Okay? So now I hope you have the concepts separated and the questions separated. Mean value theorem is about slopes, and when the slope of the instantaneous rate matches the slope of the average rate. And average value is about finding that y value that's the average of all the given y values and use that formula. So they're very, very different concepts. But now I'm actually going to show you how they actually are very closely related to each other. So before I get into that, though, make sure you guys are comfortable with the separation between those concepts and how the question will be asked. That's important because on your homework tonight, I'm going to ask two different questions. Sometimes I'm going to ask for the average rate. Sometimes I'm going to ask for the average value, and you need to catch that. So pay close attention to that keyword difference. Furthermore, I want you to also make sure you're aware of what they are, not just how to do it differently, but what's different about them. This thing's all about an average slope. This one's all about an average y value. Okay? But now I want to talk about how these two theorems are actually the same, like not the same, but how they're actually related to each other, what they have in common. And it turns out what makes the mean value theorem and the average value theorem actually quite closely related to each other is the fundamental theorem of calculus. So let's start there. As you guys may recall, the fundamental theorem of calculus says this. You integrate your function, so the prime becomes just a normal f, and you plug in the upper and the lower limits, and you subtract them, right? So there's your fundamental theorem of calculus. Now I want to show you something interesting here. What if we divide both sides by b minus a? I know that seems kind of random and average, but or random and odd, but let's do that really quick. Let's divide both sides of this equation by b minus a. Well, what the heck? What do you know? There's your average value formula right there, isn't it? But wait a minute. Isn't that the average rate of change? Wow, these things are actually quite closely related to each other. So this means that the average value of the derivative actually does equal the average rate of change of f. Okay, so remember before I said that there is a difference between the average rate and the average value, but now it seems like I'm telling you they're the same thing. I'm not. There is a difference here. It's a very subtle one. This is the average rate of f on the left side here. That's the average slope of f. But on this side, this is the average value of the derivative. But doesn't that make sense? The average rate of change of f, which is the slope, right, of f, that's the slope of f, should be equal to the average derivative, which is what this is saying basically, the average derivative value, which is also the slope of f. Now, the reason why you might be a little confused is because of this derivative here. But if I were to erase this statement is no longer true. It's not true that the average value of f is equal to the average rate of f. That's not true. But the average value of the derivative of f is equal to the average rate of f. So it's kind of interesting, and that will come in handy also on a homework question. So as you guys might have recalled earlier, I shared with you guys the ways that the question could be asked. I said the question will ask find the average rate, and this one will say find the average value. But technically then, if you're asking find the average rate of f, let's extend that a little bit. If I say find the average rate of f, that's actually the same thing as saying find the average value of f prime. So both of these mean the same thing. The average rate of f is the average value of f prime. This over here is the average value of f. That's different than the average value of f prime. But the average value of f prime is equal to the average rate of f. So that's an interesting little relationship that they have. So even though the concepts are almost entirely different in terms of what they find and how you go about finding it, they actually are very closely related to each other through the fundamental theorem of calculus. And you could just take that fundamental theorem of calculus, divide both sides by b minus a, and you get those two statements that I shared with you on the other slide. And it shows you how they're related. The relationship is that the average value of the derivative is equal to the average rate of change of the original. So that's where I will stop for the day. Go ahead and do the rest of your homework, and we will see you guys in class. Have a good one.